my good friend Dan. We're going to talk to you a little bit here about some spring recipe type actions. If you're interested in code, you can always go get that from the GitHubs, of course. So trust us, that's not a bad QR code. That's going. I don't know about you all, but I always feel a little weird every time I see a QR code. I'm like, I don't know about this. And lots of places now, it's like, no, you have to use the QR code. We don't have menus anymore. And you're like, really? What am I really clicking on here? But it's trust me, it's all good. It's all good. We wouldn't do that to you. So that's where the code lives if you are so inclined. I also have to briefly talk about Spring Academy. If you're interested in this space, you want to get certified, we can help you with that. So go ahead and check that out. You can see all of our smiling faces. So who the heck are we? All right, well, hi, my name is Nate. I've been doing this longer than I care to admit. I have a wife and I'm the proud owner of a teenager who is now driving. Still not sure how to feel about that. It's very strange. It's only been like 2 weeks. So I'm still adapting. I will say it's been very nice not to have to be the Uber of the house anymore. You know, I realized when my son was younger that parents were the original rideshare app as well as the original ATM, right? That is our job. I live in the great state of Minnesota, the Twin Cities. I am so happy to be down here where the temperatures are above freezing. It's very nice. I got 10 inches of snow before I came down here, so I'm glad to not be dealing with that. I've been doing software longer than I'd like to talk about. Best way to describe me is architect as a service. First person who called me that, I thought, yeah, that seems fitting. I go places, talk to people about architecture, and then I sounded the acronym out in my head and realized it probably wasn't a compliment. I'm a DevRel person here for VMware, and I've written some books, teach at the University of Minnesota, do content-y stuff, whatever you want to call that. I'm so happy that spring is here because that means I get to go play golf and ride my bike outside again. You can follow me on Twitter and other places. You can check out my horribly out-of-date website. I also do not quite every week, but most Mondays I get on Twitch and YouTube with smart, interesting people and yap for an hour or so. Chris Judd's been on it, Craig's been on it, Dan's been on it. Several people you see floating around here this week have been on it. So I'm always interested in new guests, so if you're interested, go ahead and let me know. Written a couple reports. You can snag this from us if you're interested in my thoughts on architecture or microservices or similar types of things.
So same thing here. I'm a husband and a father on the opposite end of the spectrum. I have 2 little girls. That's my beautiful wife, Jen, our daughters, Isabella and Juliana. I'm up every night with the girls while he's worrying about the teenager driving. I've also been doing this a long time. So a little over 20 years. I've worn a whole bunch of different hats in this industry. I often joke that I've been a Spring developer advocate long before VMware was paying me to be one. I'm a huge fan of Spring and the Java ecosystem. I'm also a content creator. You can find some info about me at danvega.dev. I like to blog. I'm on the YouTube. I like to create courses, and you can find me on Twitter at @TheRealDanVega.
You know, it's funny, when your kids are young, you just wish for them to get older so you get more sleep, and then they get older, you realize, no, it's the same amount of sleep, it's just for different reasons.
It's always just different problems.
Right, it's just different problems.
That's what I hear.
Yeah, exactly.
So I also run this show called Spring Office Hours with my friend Deshaun back there. This is a really good opportunity for us to kind of connect with the community, talk to people, and find out, like, what questions do you guys have? What problems are you facing in your day-to-day development? So if you haven't heard of it, head over to springofficehours.io. It'll forward you on to that long link at the bottom where you can watch some past episodes. We stream every Tuesday at 3:30 Eastern. We did one yesterday here in another room. That was fun. But again, really great chance. This is kind of, we started this with the idea that we wish we had this resource when we were in this position. Like, we have questions, where do we ask them? This is a great place to ask them and get them answered. So go ahead and check that out.
All right, so let's talk about Spring recipes, shall we? So Java, Spring, been around for a while. You know, I think Java certainly is old enough to rent a car, and I think Spring can almost drink, somewhere in that ballpark, plus or minus. Now, a lot of us had the luxury of kind of growing up with Spring and Java, and so each sort of additive piece wasn't that big of a change. It was just, oh, okay, now I have to learn about this, now I have to learn about that. And it occurred to me a couple years ago, I was talking with someone who was sort of fresh out of school, and they'd never heard of the Gang of Four patterns before. And I realized, okay, I took that for granted, but then again, I sort of grew up with that. And so you realize that if you're coming into this space today, it can be incredibly overwhelming because there are so many things here. And you think, well, where do I even begin? What are all these pieces? And so Dan and I will touch on a lot of this here today, try to cut through some of that clutter. And one of the things that is one of my hobby horses as an architect is to get people to understand these are just tools. The challenge for us as software engineers is to know when to pick up which tool, and also to know that a tool exists. You know, there's lots of times where there is the perfect tool to fix this problem, and if you don't know about it, you've just cost yourself a whole bunch of time because you didn't know that was even there. Yeah, I remember years and years ago being on this first project, and someone said, hey, we want you to go capitalize things, and here's this weird function that somebody wrote to do that. And it was the most god-awful thing I'd ever seen. It had like 16 parameters. I'm like, this is nuts. This should have like one parameter, the string to capitalize. And so I looked around, and sure enough, the language already had that feature. So I just used it. No one else on my team knew the language had that feature because, well, we had this other thing, and that's how you do it. Right? So it's important to know that these things exist. So that's what we're going to try to touch upon today. We'll talk a bit about getting started, talk about upgrading, web apps, near and dear to my heart, databases. Now, I'm a front-end guy, so I always thought databases were like squirrels that just sort of put the data up in a tree or something like that. But Dan assures me there's more to it than that. Touch on Spring Cloud, security, a little bit on testing, production. You know, we'll see where the time genies leave us. And then maybe there'll be some time for QA. We'll see. We'll do it live.
All right.
So, getting started with Spring Boot. Always an important place to start.
All right, so we're going to go through kind of a problem and a solution approach. So we'll kind of talk about a problem, and then we'll come up with a solution for that problem. So our first problem is, hey, you want to upgrade your application to Spring Framework 6 or Spring Boot 3, but your team or architect or manager is skeptical. How many people are in this boat whenever you talk about upgrading something?
Is anybody still on Java 8? Just asking. Okay.
There's always.
All right. Yep. They're always there. It's okay. It's okay. I understand.
It's
This is a safe space.
Yeah. No, we're not going to tell anybody.
We'll commiserate later.
Wait, hold
it's
on.
fine.
I got to get on Twitter.
Yeah. Hang on. Tweet that out. I understand how hard this is. You know, I've been in this space. I've done a lot of currency projects. I know how challenging that can be. It's very tempting to just keep kicking the can down the street. Here's the thing I want to tell you. The status quo is not free. There is a cost to the status quo. We all kind of get lulled into that. Everything's fine. Would you get on an airplane if the airline said, oh, no, the plane's fine. We haven't done any maintenance on it for 5 years because it works, so we don't touch it. You'd be a little skeptical of that, wouldn't you? And yet we're running applications 24 hours a day, 7 days a week, 365 days a year, and it's like, well, yeah, we're still on this old thing, but it works mostly. So why would we want to upgrade? Well, features, functionality, big part of that. Baseline support for Java 17, meaning you get access to all the language features that are coming along in 17, and 20 came out like 2 weeks ago-ish, thereabouts. Native executables, if you're interested in trying to make this thing smaller, use Graal, etc. Better observability. There's also support, by the way. This tends to be the one that moves the needle when you're talking to management. I've been in those situations where people are like, well, but where do we get a support contract? I'm like, okay, that's possible. You can buy that from us. We'll happily sell that to you. But without that support contract, 2.7, you're done in November. And so you need to start thinking ahead, like, how are we going to move off of that? These take time. You've got to be able to prioritize that within your own ecosystem. And so it's important that we take a peek at that. All right, so here is the very nice graph that shows you what we're talking about in terms of support. This is the kind of thing that typically will get architect/manager to go, oh yeah, you're right, we don't want to be on that thing that's outdated. Although I will admit that's often the piece that really convinces people, yes, we definitely need to do that. There's nothing quite like a deadline. You see that in sports all the time. I think eventually Aaron Rodgers will go to the Jets, maybe. I don't know. Your guess is as good as mine. Spring, a little bit longer in terms of support, but same thing. You've got to be looking ahead. We don't want to wait until November to go, oh man, we really need to move, don't we? And then now you got to rip the Band-Aid off, and it gets so much harder. The other aspect of this is small batch is good for more than just like bourbon. I'd rather do this in small steps. The longer you wait, the harder it gets. Mm-hmm. You know, we've all had that experience, whether it's trying to keep your house clean, you know, if you wait, and it's like, oh, it's spring, let's do a big cleaning. It's a lot harder than if you just pick up a little bit every day. Now, I know that's not easier said than done, but that's got to be part of the mindset here. So work in small steps. It's easier, it makes it simpler, you have less risk. Trust me on that. I would rather avoid the big bang, rip off the Band-Aid, cross our fingers, hope it all works. What could possibly go wrong if we try to make a huge jump?
Right. All right, so our next problem is you've thought about this.
You've convinced them.
You've convinced somebody. Now you want to upgrade your application to Spring 6 or Spring Boot 3, but you aren't sure about how to go about this process. So how can we go about this?
Well, guess what? Work in small steps. That should be goal number one. Get on to the next version of Java. That can be a bit of a challenge. Get on the latest version of 2.7. Check out your dependencies. There's been a few configuration property changes. There is a Spring Boot properties migrator that will help. One of the bigger changes we're going into, of course, are the Jakarta EE10 issues with changing import statements. That tends to be a fairly mechanical switch, but it is something that you have to be aware of for sure. There are migration guides out there to help you. They are very detailed. They will walk you through this process. There is some tooling that will help. Yeah, I mean, there's great information here, links to other helpful information. So this is out there for you. We're not just like figure it out, roll the dice. There's pieces out there as well, an open rewrite on how to get up to Jakarta 9, 10, et cetera. So the pieces are there. Some of your editors of choice can help here as well. Take advantage of the tools that are baked in. But again, work in small steps. All right, that should be the key step here. Do not try to rip off the Band-Aid, do it all in one big bang conversion. That way lies madness. Now, I heard there's web apps. We still do web apps, right?
We are building lots of web apps these days.
Thank goodness. So I have written and used hand-rolled validation techniques throughout my career. Please tell me there's a way that I can get away from that.
Yes, so we don't want to handwrite these validation things. In Spring, we actually have a solution for that. So the Spring Framework provides support for Java Bean Validation API. So what this looks like, say we have a REST controller here that accepts a coffee, in turn calls a coffee service to create a new coffee. So we have that, we are taking this in through a request body. It may look something like this. We create a post to /API/coffee, we're sending in some JSON. In this case, everything's fine. We're passing in a name, we're passing in a price. In the real world, in the perfect world, this is all going to work just great. But we know that things are not always going to be perfect, right? What if I send in a name that has no name? What if I send in a price that's some ridiculous price that we don't want to charge?
Well, I don't know. Have you been to Starbucks lately? That's not that far off.
That's kind of close, yeah. So what if I send this information in? How do I kind of safeguard against this? So what we can do in Spring Boot here is include a starter. So we include a Spring Boot starter validation. Now you'll need to include this. This used to be part of the web dependency. It's not anymore. It's a separate dependency, so pull this in. Once you pull this in, now you can add the @valid annotation in front of that request body. And what this tells Spring is, hey, I want to perform some validation on the incoming request. And how do we perform validation on that? Well, we can add some annotations to our object, our model object. So here I'm saying, hey, my name, I want to make sure that it's not empty. So go ahead and validate that. I also want to make sure that my price of the coffee coming in is not more than 10. So in this case, $10. So once I add those annotations, now I can come in here, and if I make a request to it again, I'll get back some information. Now this is saying, hey, this is a 400. This is a bad request. We have 2 errors here. By default, this is the error you're going to get back. May not be that helpful. Maybe you want some more helpful information as to exactly what went wrong. If you include 2 properties here, this is the include message and include binding errors, which, by the way, if you're using Spring Boot DevTools, will automatically turn these on for you. So I like using DevTools because it sets a lot of sensible defaults for us. So it'll set these 2, and then we get a lot more information about the errors that are going on in our application.
I saw yesterday on a building as I was walking back to the hotel, it said, Happy 404 Day. And I thought, all right, cool. I dig it. I got in a cab once, and the cab number was cab 404,
Nope.
and we all laughed, and the cab driver just was staring at us like, what is wrong with you people? We thought it was hilarious, but anyway, I guess that's just one of our things. All right, now, I know you've talked a lot about GraphQL. I've seen you even give presentations on GraphQL, but I have no idea how to get started with GraphQL.
All right, well, this is great. In Spring, we have a project called Spring for GraphQL that supports building GraphQL APIs in Spring. So really what this is a combination of a collaboration between 2 teams. So GraphQL Java is kind of the implementation of the GraphQL spec in the Java world. There are other ones. This one's been around since 2015, started by Andy Mark over at Atlassian. The GraphQL Java is basically a pure execution engine. It knows how to take these requests and execute them. There is no server transport. There's no HTTP. There's no I/O, and that's where Spring comes in. Spring, again, a joint collaboration between both teams. It adds support for requests over things like HTTP, WebSocket, RSocket, and it does what Spring projects really do for me, which is make those complex things easy to do. So that's Spring for GraphQL. There's really two sides of this, right? There's a client and a server. On the client side, we may forge a request. So we're writing a query here that says, here's what I want my data to look like. The really nice thing about GraphQL is you're only going to get back the data that you asked for. And this is very important. So there's no more, hey, select star from customers and give me all that data back. You're being very explicit as to what data you want to be returned. So you send it over to Spring. We have a single HTTP endpoint there. The GraphQL engine underneath the hood knows how to resolve all of those fields to data fetchers and return that data to you. So the way that this works on the Spring side is there's a GraphQL schema. This is the first thing you kind of need to learn when you're building out this Spring application. The nice thing about this schema is it's a very simple schema based on just a few types. And so we have an object type here. So here we're creating a coffee. It has a couple fields in here, ID, name, and size. And each of those fields have types. So one of those types is an ID. The exclamation point just says, hey, this is never going to be nullable. You don't need to worry about that. We also have a built-in scalar type. There's 5 of them or so. You can always extend that using GraphQL Java. And you can also use other things like enumeration types and their input types, interfaces, etc. So once you have your object types, those are most of the types in your schema, but there are 3 special operation types. We have a query, we have a mutation, and we have a subscription. A query is a way to read data, so I want to get one coffee, or I want to get all the coffees. Mutation is I want to mutate data, so I'm going to create a new one, I'm going to update one, I'm going to delete one. And a subscription is similar to a query, except that we leave a kind of connection open so that we can keep reading data. So now that I have my object created, I can create a query. I want to find all. The brackets around the coffee says, hey, I'm going to return a collection of these objects. The exclamation point again says it's not going to be null. Find one says, hey, I'm going to take in an argument here, and that argument is going to be of type ID. So these arguments are really how you start to stitch these graphs together and create this really nice API. On the Spring side, you create a controller just like you would. We annotate it with @controller. That's how we find it. We have these annotations that help kind of hook up the method to the method that we defined in our schema. So we can use the long form of this, which is @schema mapping. We also have a shortened version of this, kind of like in the REST world, we have request mapping, and then we have specialized versions of that. We have a specialized version of this saying, hey, this is going to be a query, and I want you to derive it from the method name. So that's how we kind of hook it up. So once it's called on the API side, it calls this and returns your data. So the other thing I really love about GraphQL and in the Spring world here is that we get these really nice developer tools. So right out of the box, you can enable this tooling, and you can jump in and start to validate your queries. I hate saying the word test, because we're not really testing them, but we're validating our queries. We're getting a chance to understand how to write these client queries. So you can write your client queries here and see if they go ahead and work. So that's GraphQL for me.
All right, so I know in these distributed architectures, I'm going to have to call somebody else's service. There's just no getting around that fact. So whether that's something somebody else in my company wrote, whether that's something from the outside world, so how do I consume APIs?
Great, so we have a lot of solutions for this in the Java world and the Spring world. So in Spring, we have a few options. We are going to talk about REST template, web client, and in Spring Boot 3, we have something new called HTTP interfaces. So I want to talk about REST template first because I feel like it's not getting a lot of love these days, and I hear a lot from people saying, hey, I don't use REST template because I heard it's being deprecated and it's going away, and that's not the case. If you read the docs, it just says, hey, we're not putting any more effort into expanding the API out. But this works perfectly fine, especially if you're in a blocking application. There's no need to bring in an extra dependency if this is all you need. So bring in the REST template. It's really easy to use. You just need to create an instance of it. So you can create a new bean. I use the REST template builder to build out an instance. And now anywhere in my application, I can go ahead and ask for that instance, and I can use it. So the API, if you look through the docs, there's a bunch of different ways different methods depending on your needs. In this case, I want to get a single object back, and I'm going to get that back using the get for object method. So you can use the REST template. If you're in a non-blocking scenario and you need some kind of another solution here, which is the web client. So you could bring in the web client. Similarly, we're going to create an instance of a web client. We give it a URL that we're going to use as the base. And then we, in kind of the WebFlux world, the reactive world, we're working with monos and fluxes. Here I'm saying, hey, use the client to go out and call random.json, retrieve that, take whatever's returned from the body and turn it into a mono. So that's the web client. We just talked about GraphQL. So what if I'm in a GraphQL application and I want to call another GraphQL API and I want to get back all the data there? Well, Spring for GraphQL has a GraphQL client and it is based on web client. So it looks pretty similar. We're going to create an instance of it. We're going to pass in our base URL and now we have a GraphQL client. So we just saw those queries that we were writing in GraphQL. We can do that here. We create a document. That's the query. We're saying, hey, give me all of the countries, and these are the properties of that I want to get back. What we'll do is we'll use that GraphQL client. We'll pass in a document, which we've created above. We'll say, hey, go ahead and retrieve this, and I want you to turn that into an entity list, and here's the type, which is country.class, and I'll return my countries. So we can do this in GraphQL as well. Once you have that, we can go ahead and use this in, say, a command line runner, execute this, and then save all those to the database. Another thing, the next one I want to talk about is HTTP interfaces. So this is new in Spring Boot 3. This allows you to just declare an interface. So you can just say, hey, I have this coffee client. At some point, I'm going to call /random. And I want to just declare this method. So you're just declaring this method. You're not providing an implementation here. You're just going to define the interface. And at runtime, we will go ahead and turn this into an implementation for you. So now you don't need to get bogged down in all the details and like, how is this going to work? Do I got to like write all the implementation code for calling this other service? All we're doing here is saying, I want you to call a service. We'll figure out how to do that at runtime for you. There's a little bit of boilerplate code you got to use. So I create a new coffee client here. I don't even remember this code. I actually create an IntelliJ IDEA live template to kind of spit this out for me. And I think at some point in the future, we may have this baked in so that you don't have to write this. But for now, you got to write a little boilerplate code to create that client. But then at runtime, we get all of that created for us. And then once you have that client, now you can just ask for it in a controller and say, hey, call that random method for me. Now, we don't know how that's working. It's going to do that underneath the hood for us. But call that random endpoint and get me my data back.
That sounds like a nice layer of indirection. I like that as an architect. Makes me happy. Makes me happy.
All right.
So we know we're going to have to work with databases at some point. You got to get data.
Man, does anybody love working with databases in plain Java?
See,
yeah, put your hand down.
For a long time, I tried doing SQL. I tried to figure that out. And what ended up happening is I did enough SQL that they wouldn't let me do SQL anymore. So I learned like that was not my skill set, and I let other people handle that. And then we got all these really cool libraries and realized, hey, wait, actually, I probably could talk to databases again. Yeah. I could make that work.
Yeah, there's a lot to understand when working with databases. You know, you got to understand things like connection strings, and now I got to create a connection, and I got to make sure I close that connection. And now, if I'm serving a bunch of requests, I probably need a connection pool, and how do I handle all that? And then the API for working with databases in Java isn't the most friendliest thing. Come on, we're amongst friends here. We can talk about it. Thankfully, Spring provides some levels of abstraction for us on top of that.
All right, so for first things first, I need to connect to a database. So how do I connect to a database?
This is really easy to do in Spring Boot. Probably the quickest way to get up and running is by using an in-memory database. This is really great for proof of concepts, demos. I just want to get something off the ground, up and running as fast as I can. I'm going to use something like H2. So how do I do this? So if I go over to start.spring.io, I'm going to select my dependencies like Spring Web. I'm going to say, I'm going to use Spring Data JDBC here, and I need to pick a database. In this case, it's H2. It could be Postgres, MySQL, whatever. In this case, I have H2. If I go ahead and do nothing, I've done nothing at this point. I just start the application up. You'll see that underneath the hood in the console there, it says, hey, I'm starting this embedded database. It's at a URL, so there's the connection string. It's JDBC, H2, memory, and then there's this random name that was generated for you. So by doing nothing, you have created a connection to a database, which is really great.
I think I could even do that. Even I, as an architect, I
couple-
feel like I could do that.
Pick a couple dependencies and click that green play button.
Heck yeah.
Now, if we want to take this one step further, we can configure a couple things. We can say, hey, don't generate that unique name. I want to give my own data source name here. So I'm going to give it a data source name of coffee. I also want to turn on this H2 console thing. It's a nice UI view into the database. So just by setting these 3 properties, I run the application again, and I get some information out here. And now you can see the embedded database has a name of coffee and not that random one. And it also says, hey, the H2 console is available at /H2 console. This means that I can go into a UI here, I can test the connection, I can connect to it, and I can write my SQL statements against my database. Again, I want to get something off the ground, prototype, up and running real quick. This is the fastest way to do so.
Pretty sure that UI was designed by a developer, but
sure
that's fine. That's fine. Okay, that's great. I mean, I'm all in favor of in-memory databases for doing demos, for quick stuff, but eventually I got to go to production, and I probably don't want to use an in-memory database. That sounds like a bad idea.
You don't want to reset your data every time?
I mean, I'm willing to try it, but I'm guessing my customers are going to be a little upset when their balances keep disappearing.
They are.
Trust us.
The good news is configuring a database like something like Postgres is just a few lines of configuration. So in this case, in the example that I'm working on, I use a Docker Compose file to spin up a Postgres database locally. You can see I've set the password and the DB. So all I got to do is go into the properties and I set that connection string. So I'm saying, hey, this is a JDBC connection using Postgres at localhost 5432. The name of the database is coffee. Here's my username and password. Once I do that, I can go ahead and start up. And oh, remember that thing we talked about, like creating things like connection pools? I don't got to worry about that. It is being handled for me.
I think even I could do that. Man, I tell you.
We're finding a lot out about you.
But, well, seriously, I mean, I'm not lying when I say I did just enough SQL that they stopped allowing me to do SQL. That's not a lie. That's the truth. That's at least part of why I became a UI guy. All right, so that's cool. I've got a database, but I really would rather do some DDL to actually get my tables created and all that. I don't want to have to figure that all out on the fly.
Right. So by default, or by convention, if you create a new file in source main resources called schema.sql, we will go ahead and run that. So here I'm creating a table called coffee with 3 columns in it. And if I go ahead and run that, it would get initiated. Now there is one thing to note, that if you're not using an embedded database and you want that file to be picked up, you need to make sure you set the property spring.sql.init mode to always, because by default it's only doing that for an embedded database like H2. It doesn't want to do that automatically for your Postgres or your MySQL databases. So if you just tell it to go ahead and do that, it will pick that up for you. And then you can also include things like, I want to insert some rows here. So I'm going to insert a few coffees. I go ahead and start my application up. My table's created. I have some data inserted. Again, just a nice way to kind of get up and running very quickly.
All right, can I do that programmatically? Maybe I don't want to write a bunch of scripts.
I'm with you. I don't like writing SQL. So I want to just do this like programmatically in Java. How can I do that? So we can use something like the JDBC template or Spring Data out of the box. Gives us the ability to not have to like write SQL statements. We can just focus on the code. And then there are a couple of interfaces in Spring that you can take advantage of. So there's an application runner and a command line runner. And these are ways to kind of bootstrap some data. So if I create a new bean called of type command line runner, I can go ahead and insert some data. So I'm using a DAO here. The DAO is like some JDBC code. And then I'm just calling that create method on the coffee. So you can use that, and then if you want to get into something a little bit more complex, you have a lot more like bootstrapping, you want to set up some data. Instead of just creating a bean, you can go ahead and create your own class that implements the command line runner. I find this easier when I have a lot more complex logic to do.
Ooh, Spring Cloud. Ooh, this sounds like my wheelhouse.
Yeah.
I'm liking this. I'm liking this a lot.
All right, so in the Spring Cloud world, we have a problem really in
distributed architectures writ large.
Exactly. We need to monitor various metrics, information or health about our service or application. How do we do that?
Yeah, so one of the things you figure out pretty quickly when you get into distributed architecture is you need observability, you need monitoring. You know, back in the day, we could just put a breakpoint in, we had all the code, we can just walk through it. And now you realize, wow, calls are going all over the place, I may not control most of this code, I don't know where the problem was, we need some data. Now, there's a lot of great tools out there. It's always important to understand that Actuator gives you a bunch right out of the box. So it'll give you a bunch of things you can monitor, a bunch of pre-built endpoints, and you can build your own custom endpoints if you need or want to. Right, so I encourage you to take a look at what is already in the box. This continues to be improved. It's the kind of things you would expect, health checks, etc. You can get in various information bits about your application. Very, very useful. One of the things that I love about Spring is how orthogonal everything is. What do? Well, you add the proper dependency and away you go. It makes your life very, very easy. And then you say, yes, I would like these to be turned on, and they're enabled, and now you've got access to them. There's different ways of doing that depending on whether you like YAML or not.
All right, so my application, sometimes applications fail.
Well, nothing that we've ever written.
No,
it's other people's code that eventually fails.
Ours are good.
Rock
but
solid.
Your application, if it is going to fail, we need to be able to handle this.
Yes,
How
absolutely.
can we handle this?
Absolutely. What's the phrase? Hope for the best, prepare for the worst. That's software in a nutshell. Things are going to break. You are going to call something that is going to have a problem. This is where circuit breaker is such a powerful pattern for us. And I always like to make sure everybody knows Michael Nygaard came up with that. I was at an event with Mike, and we were chatting, and somebody came up and somehow circuit breaker came up, and this person's like, yeah, it was so great that Netflix created that. And Mike's like, oh, really? Do you know where they got the idea from? Let me show you my book. So the idea here is let's have an abstraction over the various implementations that you could have of a circuit breaker, allowing your engineers to switch that out as they need or want to, and you've got this API that you can work with. Very straightforward. Spring Cloud Circuit Breaker, you got a few different options for implementation details. So what do? Well, we include the proper dependency. Imagine that. No one could have predicted this. And then we create our circuit breaker configuration. You can just say, hey, this is the one I'm going to use for everyone. You can have specific ones for specific instances, completely up to you, however you want to do that. Lots of different things you can tweak. And then you take whatever this vulnerable call is, you wrap it in the circuit breaker, and then when something bad happens, you go ahead and redirect to whatever the appropriate fallback mechanism is. That could be a default answer, that could be another service, that could be, sorry, we're down for maintenance, whatever makes sense. The only answer I can give you, in fact, the only answer I can give to most questions in my space is, it depends. All right, but this is, to me, frankly, a requirement in the systems that we're building today. This works like the circuit breaker in your house. If there's a surge, the circuit is open, preventing that surge from going and blowing out everything in your house. Everything's good, the circuit's closed, we continue to make the calls. It's a little more automated, which is nice. If you've ever had a circuit trip in your house, then you got to go figure out, wait, where's our circuit box again? And you stumble down there in the dark and you're trying to figure out which switch it was. Or worse, if you have to fix something and figure out, hey, which circuit is this on? You keep flipping breakers until you have to reset every clock in your house. It's good times, it's wonderful. But you can't afford to just expect everything to work.
Or you don't want to just return 500 error
That's
messages?
probably not a good idea. Customers don't like that. They'll eventually go to another provider of that service. You want that. It also helps you sleep better at night, which is good. I hear sleep's really important, so
Yes.
let's try to get more of that wherever possible.
All right, so our application is getting more demand. We need to start scaling it. We've adopted some event-driven approach, some event-driven architecture. But you don't want to tie yourself to one particular message broker.
Well, now we have two problems, right? Isn't that how that works?
Yes.
Of course, I always have to caveat whenever we start talking about event-driven is, well, what do you mean by event-driven? There's probably at least 4 different patterns that make up that concept. We get a lot of talking back and forth about what everybody means, but let's just assume you're working with some kind of a message broker. As an architect, I never want to paint myself into a corner. I never want to be stuck in a situation where I don't have a choice. I've got to work on this thing. I want that flexibility. So if we need or want to change brokers, we can do that with minimal fuss. So that's what Spring Cloud Stream gives us. So if I need or want to switch out that broker at a later point, I can do that. If you can think of a broker, there's a pretty good chance there's either bits that we maintain or bits that are maintained by partners. Almost everything out there has something. So pretty good opportunity here to, again, have that layer of indirection. How do we access it? Well, same way as before, you add the proper dependency. Again, I love that because I like patterns. I like things that are easy for my little brain to remember. That's a good thing. So if and when you want to do that, you now have the ability to swap things out.
All right, cool. So we have this service. It's used by a lot of people downstream. We're in an organization where 500 other teams are calling our service. We don't want to just be changing things because we own the service and we want to change things. We have to remember that other people are using this service. So how can we introduce those changes?
But it's my service, and I want to change it,
Right.
and you should just deal with the changes.
It's called V2.
Right, just V2, it's fine. V3, V4, what could possibly go wrong? This is the reality of these distributed architectures. You may not even know all of the different services that are calling you, and you still need to be able to make changes on the fly. Spling, that's a new one. Wow, that's cool. Spring Cloud Contract allows you to simplify that. You say, all right, we're going to create this contract. As long as we both obey that contract, we can both make whatever changes we want. I can change my side, you can change your side. We've got a set of tests that we can run, and as long as those tests continue to pass, we know we haven't broken each other. That's a huge win. So I'm a big fan of this concept. You know, this is that whole idea of client-driven contracts. I love that. Same basic approach. We add the right dependency. I love that. It's so easy. How hard could it be? And on the other side, you say, all right, I'm going to add this dependency so I can run these stubs that you generated and give to me. And again, now both sides are free to make whatever changes they want. That brings us to security. I hear security is important.
It's a little bit important, yes.
And I thought if I just hide the URL, no? Is that not
maybe we can
obscurity?
hire a security guard to stand in front of our servers.
Right, I think that would work. All right, so as I'm upgrading, it turns out there are some changes to Spring Security. So what do I need to be aware of? What do I need to change?
Yeah, so if we're moving to Spring Boot 3, Spring Framework 6, we are pulling in Spring Security 6. There are some changes. There are some deprecations too, so things got removed. We need to talk about those. So Spring Security introduces a new component-based configuration. So what I love about Spring Security is that it's secure by default. We are basically locking everything down, and we need to open things up. Once we start our application with Spring Security on the class path, we get this default password. Things are all locked down. At some point, we're going to have to write our own configuration because we're not going to use the out-of-the-box configuration. In the past, we used to do this by creating a configuration class that extends Web Security Configure Adapter. Just rolls right off the tongue.
Yes.
We don't do that anymore. This is how we had to do it before. We had to extend that and then override the particular methods. Going forward, you are not going to be able to do that. That has been deprecated, removed. Now we are going to create a configuration class, and we're going to move towards more of a component model. So here, I'm creating a new bean of type security filter chain, which takes in HTTP security, and what will return from that is the HTTP security. We can also do this with users. So if we wanted to set up an in-memory user, we can create a bean, we can go ahead and return that type, and we can set up our user there. So we're moving towards this model. Here's a little bit more of an in-depth security configuration. So the second change is that we used to use authorize requests. We don't use this anymore. That's been deprecated in favor of authorize HTTP requests. So I wrote a blog post on this and did a video on this as well. That auth passing that in, that is now the new Lambda DSL. So there's a way that you can kind of chain these together or use the Lambda DSL, which I'm using here. But I'm using that, and then I'm saying, hey, I want to go ahead and use a request matcher. The request matcher is like the third big deprecation I want to talk about. So we might have used something like an ANT matcher or a regex matcher before. We're using request matchers now. But all we're doing here is saying, hey, anybody who hits the root endpoint, go ahead and permit them. Anybody who hits API/coffee, any of that URL, I want you to make sure that they have a role of admin. And then guess what? Anything else I want to be authenticated, because even though we've overridden the defaults, we want to make sure we kind of stick to Spring Security's principle, which is secure by default. So anything that falls under that, let's make sure it's authenticated. And then we're using HTTP basic, and we return that. So you can also use multiple security configurations. So something else that was added was that security matcher. So here I have one configuration where I'm saying, hey, these are the things I want to set up for the H2 console. I want to make that available to anyone. I don't want you to have to log in to get to that. So I'm using that configuration there, and then I'm having the other configuration for everything else. And you can define the order of those by using the @order annotation. And order matters in Spring Security based on the bean types and all of the order in the configuration itself.
All right, so I've got this nifty REST API, and I really want to take advantage of JWT, which, by the way, you've got to love any acronym that embeds an acronym in it. I think that's like peak geek. If we can just get a few more in there, it'd be even better. It's just acronyms all the way down. I have no idea where to begin, though. How do I make that happen?
This is great. I had no idea where to begin either, because I had the same problem. You know, a lot of the times, especially on Spring Office Hours, we feel like we're an extension of the community. We're talking to people, and people were having this problem. I'm like, I have that problem too. Like, how do I fix this? And so I would go out and I'd search the web and I'd say, how do I, secure my REST APIs? And with something like Spring that's been around for 20 years, you're going to find a whole bunch of different answers, right? And that is a problem that the developer advocacy team is trying to solve. Like, how do we get the right answers out to the community? So I would go out and search, and I keep finding the same tutorial over and over again, and this doesn't seem like a good answer. This doesn't seem easy to me. So I did what anybody with access to the Spring security team did. I asked them. I said, hey, there's got to be an easier way to do this. And they said, of course there is. We have built-in support for OAuth 2 resource server in Spring Security. So I have a couple of videos and a couple of blog posts on this if you want to go into this in depth. But ultimately what this is we have a JSON web token. So we have the different parts of it, a header, a payload, and a signature. How do we use this string? So we have our application, we call our REST API. By default, we're gonna lock that down, right? We're gonna say nobody can access that. So we're gonna get a 401 back. What we're gonna do is we're going to use our client to log into the application. So this could be through whatever authentication mechanism you want. Once I log in, I'm gonna get back a JSON web token. Once I have this, now I can send this in subsequent requests. And now if that's a valid token, I'm gonna get that 200 back, right? So this is a good approach to it. But how do I do it? So in that configuration we just looked at, there's an option for OAuth 2 resource server. One line instead of all of the things that I saw were writing your own custom JWT filters and adding in all of these like different third-party libraries. So we add that in. We define an encoder and a decoder. Once we have those, we can go ahead and generate a JWT token with everything that comes with those dependencies. Now, when you go to start.spring.io, if you pick OAuth 2 resource server, that's all you need. It actually brings in Spring Security with it for you and gives you all the tools that you need to kind of build this out. And if that is a really good solution for a lot of common problems. So if I'm just building a front end in like Vue or React and I want to call a REST API, that works out great. If you start asking questions like, well, what about invalidating tokens and refresh tokens, and maybe I have a gateway and I need to secure a bunch of different services, then we can start talking about something else. Like we have a product called Spring Resource Server or Spring Authorization Server, and that can solve a lot of those problems for you as well.
Yeah, I'm not gonna lie, it's really nice to have the Spring team on Slack.
It is. The Spring team, everybody, I'm just like, I don't
so
know how to do
handy.
this.
We should probably test our application, right? I mean, I hear that's a good idea.
It is important. It's one of those things we know we should do.
We're not allowed to just throw it over the wall and make it QA's problem anymore. So
No.
I've run into this problem in the past. We're writing lots of tests, and that test suite takes longer and longer and longer to run, and then you start going, oh man, the builds take forever, and people start getting grumpy, and they don't run it locally, and they wait till they check it in, and then they ignore the build break because it takes half an hour, 45 minutes.
Yep.
Is there a better solution to that?
Yeah, how many people write tests in like a greenfield application and they run really fast, and then a couple months down the road, these things start to slow down because of the complexity of the application? There's a reason for that. And the reason for that is as our application grows, so does the application context, right? That is the kind of container that we're putting in all of these classes and beans into a context that Spring can manage for us. So as our complexity grows, our application grows, so does this context. So every time we want to start like an integration test, we are loading that entire application context. Well, slice tests in Spring allow us to kind of test just a particular slice. Like, hey, I just want to test this web layer. I just want to test this database layer. I want to test this GraphQL layer. How can I do that? So slice tests allow us to kind of test those layers. There's a bunch of different slice tests. I mentioned GraphQL, JDBC, or maybe you want to test JSON or a REST client. There's a whole bunch of different slice test annotations. You can go ahead and look at one of the examples is the WebMVC test. And the important part is this, using this annotation will disable full auto configuration and instead apply only configuration relevant to MVC tests. So we're only going to load things like controllers, controller advice, and then all of those in that list. So we're not loading the entire application context, just what matters to that test. And again, I am very much a person that if I have to write a test and it takes a long time to write, I'm less inclined to write more of those tests in the future. I need that fast feedback loop. Long are the days of compiling Java code and walking away for 20 minutes to go get a cup of coffee.
What are you doing? Compiling!
I need that fast feedback loop. So Here we are in a web MVC test, and we're saying, hey, I'm going to mock the MVC. I'm going to go ahead and mock out my coffee repository because I don't care about the database in this case. And I'm saying, hey, go ahead and find all and make sure you return a 200. So given the find all method, I'm going to go ahead and perform that. And again, this is going to run real fast because we're not loading everything else that is starting up in the application context.
It's interesting that coffee keeps showing up in your examples. Can't
Here's the
imagine why.
theme, man.
Right.
Here's the theme.
Now, again, databases are always a little bit of a mystery to me, but I know at some point I'm going to want to write some tests against that layer, and I'd really like to use the same database we use for production, but I don't want that to take forever.
Yeah.
How do I do that?
So in the past, I'm sure a lot of us have done this. We use something like an H2 embedded database to run our tests on, but we use Postgres or MySQL in production, and so there's a mismatch there. And there's always going to be one of those little edge cases where we write some particular SQL that is not going to work in test or production. And so a good way to catch those is to make sure we're testing against the same database that we're using in production. A project that I really love is called Test Containers. I'm sure Sergey or Oleg is doing a talk on that here. Test Containers, it's a way to basically provide a lightweight throwaway instance of common, anything that can run in Docker, basically. So databases, services, Selenium, browsers, anything. And what I found is that it's really fast, which surprised me the first time I used it. As we kind of said, testing's important. We all know this. We hear this. We understand this. But it can also be very hard. Testing can be hard. There are so many different ways to test things. And I think, this thing our coworker Cora says really has stuck with me a lot. And you have to make the right thing to do, the easy thing to do. So again, if you make it easy for me to write tests, I'm more inclined to write them as a developer. If they are really hard and they take a long time to write, I'm not going to write them. And unless my boss comes over, pounding the stick saying we don't have enough test coverage. So Test Containers does this for me. So instead of having to spin up my own Docker instance and figure out how all of that works, what I can do is mark a test with @testcontainers, and I can say, hey, here's a container that I want you to go ahead and start for me. That Postgres Alpine is actually the image name out on Docker. Right now, I believe this only works with Docker. I don't know if it works with anything else. I'm not sure about that. But this is using a Docker image. And now what happens when I want to write an integration test against that database, I'm saying, hey, go ahead and call the repository's find all method. And now instead of using some in-memory database, it's actually spinning up a container. It will do the execute, it will call those DDL scripts, or if I'm loading some data programmatically, it will do that. We can insert some data if we want. And now I'm calling find all, and I'm saying, hey, against the real database, I want you to go ahead and execute this. And again, what really surprised me is this is really fast. You would think spinning up a container, then doing the application load, and then calling it. You would think that this would take some time, but it's surprisingly really fast.
Production, that's a good place to go. I think, as Josh says, it's his favorite place. The second favorite is start.spring.io.
Yes, so I always use this image because I feel like Josh is Buzz Lightyear, just telling
production
us we should
and
go
beyond.
to production. So production is important. So your organization uses Docker to containerize your application.
Right. Makes things simpler. So the beauty here is you can leverage cloud native build packs. So as an architect, I completely echo Cora's statement. We want to make the right thing to do, the easy thing to do. I want my developers to basically fall out of bed and do the right thing. And I want to also make sure my developers are fixated and focused on the things that matter most to our customers. One of the things that I try to get across to my grad students, to people I interact with, is our customers want features and functionality put into production reliably and repeatably. Everything else is noise. And I know we get really excited about technology. We love it. I mean, that's why you get into this industry. It's fun to play with these things. I joke it's your birthday every day because there's always new toys to play with. Customers want us to get features and functionality into production. So how do we do that? We need that to be as repeatable as possible. Having something like a native build pack is immensely useful because it takes one more piece out of the equation for me. I think Docker's great. I think containers are great. I've also noticed a lot of organizations, when they first go down that path, there are 1,000 ways of doing something. Every developer has a slightly different way of doing it.
Deshaun and I say every week on Spring Office Hours, friends don't let friends write Docker files.
Right, right. Take advantage of pre-existing things. You know, it just, I don't want to be in a situation as an architect where I'm like, boy, I'm not sure if we're vulnerable to that or not. I don't know how many apps have that problem. We need some consistency here, right? And that's where having build packs can be so incredibly useful, in my opinion.
And if you write a Docker file in one app and you do it in 10 other apps and something changes,
Right,
guess
now
what
I
you're
got to go
doing?
find them all, and yeah, it's bad problems.
So you want your application to start up faster and take up less memory. Do we have a solution for that?
Yes, absolutely. We can now compile down to native executables. All right, so this is baked in. This is a huge improvement, and it's amazing if you've ever seen the demos of how much this will change both the size and the startup speed. Now, there's trade-offs here. This is software in a nutshell. It's all trade-offs. So we're giving up some of the dynamicism that the JVM gives us, but in return, smaller footprint, less memory, faster startup time. It's all what makes the most sense for this particular application. So we now have this baked in. So we've got Graal VM native images. Yeah, I think that's very useful when you need it. So how do we add it? Well, guess what? We just go to start.spring.io and say, hey, I'd like to do Graal, and you add that dependency, and away you go. You're off and running. Moral of the story, a lot of things here. It's a sprawling ecosystem. We know how intimidating that can be. You know, Jakob and I talk about this from an architectural perspective. You know, if you're an architect dropped on a Spring project that hasn't been doing Java for a while, it can be overwhelming and intimidating. Hopefully, we've given you a little bit of advice around that. We've maybe shown you a couple things you didn't know were there. We've given you some reasons to upgrade. I'll say it again, the status quo isn't free. You know, we love to think if we just stay where we are, that's the best plan. Not always. That's costing you something. These are all tools. Challenge for us is knowing when to pick up which one. So hopefully we've helped a little bit with that here today. Again, if you want information, QR code. He loves QR codes. I'm still trying to figure out the best way to generate them, but you know,
there's not an easy way. You go out and search for it, and there's 25 different ones.
There are apps now for it.
And they're all they're all very spammy.
Right. Always gives you a little bit of pause. You know, one of the most fascinating changes for me is I've noticed this with my students. I've noticed this with audiences. It used to be back in the day we didn't all have these really good phones in our pockets, and I've had to watch as people's phones go up. Like, oh wait, they're taking a picture of that slide. I better not advance it quite yet. So that's one of the new aspects of being on this side of the podium is watching the cameras and see what kind of trouble that gets us into. So, thank you for hanging out with us. We appreciate it very much. Cheers.